Hey, in this lecture, let's explore about CPU clock hertz and the OSTick frequency. These two are the important configuration items of the FreeRTOS kernel configuration. Now let's explore about the CPU clock hertz first. Okay, so the CPU clock hertz. Okay, so as I said, must be initialized to the clock frequency which you are using in the microcontroller. So as this describes, this is normally the same clock that drives the internal CPU clock. Okay, and this value is required in order to correctly configure timer peripherals. The FreeRTOS will be using this value to properly configure some of the timing related functionalities. Okay, so your job is to properly initialize this macro. So in our case, as I said, if you are using Atmel Studio, FreeRTOS config.h will be added to your project automatically under config. Okay, and here you can see the config CPU clock hertz is initialized to sysclock get CPU clock hertz. Okay, so this is actually specific to the Atmel Studio. So in Keil you may not find this function. So this function is a service given by the Atmel Studio. Okay, so whenever you create a project using Atmel Studio for Atmel microcontrollers, every microcontroller will have this function, and this function will actually return the value of the clock frequency used. Okay, that means the clock frequency for which the driver has configured your microcontroller. Let's go inside this function, and this function is implemented in sysclock.h. Okay, so here you can see here it is returning sysclock get main hertz. So that means the value which is returned by this function will be returned over that. So let's see what this function is doing. So this function basically turn the current rate in hertz of the main system clock. So for example, if microcontroller is configured for 5 megahertz, okay, so then you have to return this number. For example, if the microcontroller is configured for 16 megahertz, then this function will return this big number. So this function basically may return the value of the 32 kilohertz RC oscillator, or it may return the value of the 4 megahertz RC oscillator, or 8 megahertz oscillator, or 12 megahertz, or it may even return the value of the clock frequency generated by PLL. So for a microcontroller there are various ways to generate a clock. Okay, so you can use an external oscillator, or you can use an internal RC oscillator, or you can use a PLL mechanism. Okay, so basically here what you get is a large number. Okay, if your microcontroller is different, or if you are not using any Atmel based microcontroller, and if you are not using Atmel Studio, then you can just initialize the number here. That's it. Okay, you need not to use this function at all. For example, if you are using a STM based microcontroller, say with an internal RC oscillator of 16 megahertz, say, then you just mention that it is 16 meg. That's it. Okay, as I said, the macro config CPU clock hertz uses the sysclock get CPU hertz function from ASF. Okay, it is provided by the ASF to retrieve the frequency of the CPU. All right. So now there's a warning. In order to ensure that sysclock get CPU hertz return the correct system frequency, the sysclock init function should be added at the beginning of the main routine to ensure that correct frequency configuration is applied during the code execution. So this is actually a common sense, isn't it? So before you execute any function in your main source code, the first function must be sysclock init. And remember that this function, okay, will return a correct value of the MCU clock frequency only if this function is called at the beginning. Okay, if you expect this function to return a correct value, you first have to call this function at the beginning of the main function. Okay, great. In the next lecture, we'll explore about the RTOS tick interrupts and the RTOS tick frequency. See you in the next lecture.